Okay, the first problem that we're working on comes from homework 4 and it's question number 5. And it gives us a function which is f of x equals x cubed minus 6x plus 8. And it's asking us to show that there are values of c for which f of c equals the first part, which is e. And basically this is referencing the intermediate value theorem, which only applies to continuous functions. And it says that for any value between a and b, because it's continuous, all of those values will exist, and it has a corresponding f of c, we'll call it that. And so I drew it here, and the first part is asking us to see where f of c equals e, and so our f of c will equal e, and our first step is asking us where our first step will begin, and so we're going to find two x values that will be less than, whose f of x value will be less than and greater than e. So looking at the multiple choice problem, that would be A, find values of f of x of 1 and x of 2 for which f of x of 1 is less than or equal to e and less than or equal to, and e which is less than or equal to f of x of 2, or vice versa. So using trial or error, we're going to find f of negative 4. So over here we'll have f of negative 4. And on this side we'll have f of negative 2. And if you plug that in, then we know that f of negative 4 is negative 32. And f of negative 2 is 12. Because e, which has the value of 2.718, because that's between negative 32 and 12, there is a c, corresponding c value, which is here. Part B of question number 5 asks us if there is a c value where f of c is equal to the negative square root of 3. And this also applies to the intermediate value theorem. And here I wrote that negative square root of 3 is negative 1.73. And so we're going to use the two x values, which is negative 2 and negative 4, and we plug them into our equation x cubed minus 6x plus 8. And we get f of negative 4 is negative 32 and f of negative 2 is equal to 12. And because the negative square root of 3 is in between those two values, we know that there's a corresponding x value, which would be equivalent to c. For part C of question number 5, we are asked to determine if there is a c value where f of c is equal to 6 million. And we're asked to use the numbers f of 175 and f of 180. And so first we'll plug those in and we'll get 5 million and some change. And for f of 180 we'll get 5 million and some change. But 6 million is not in between those numbers, so we cannot determine if there is a c value for f of c which equals 6 million, because 6 million is not in between those numbers. But if we go in between the range of f of 180, which is 5,800,000 and some change, between f of 180 and f of 185, which is over 6 million, we know that there is a c value for where f of c equals 6 million because it's a continuous function.